Today, new notes, what we're taking a look at is 11.3, dilutions. So today we are taking a look at dilutions. So first of all, the concept, a dilution is made by adding pure water to an amount of a concentrated solution. So you take a concentrated solution, a solution with a bunch of salt or sugar in it. It's really, really concentrated, and you dilute it down by adding water, and it's not so concentrated. So here's the idea. Me and my beakers. Let's call this 1 liter. We'll make the math easy here for our example. And let's say we have a concentration of 5 molar. We'll say each dot is a mole. I know it's not really how it works, but we'll pretend. We'll call this a 5 molar solution. Again, what does a 5 molar solution mean? It means 5 moles per 1 liter. That's what big M means, moles per liter. Would be helpful if we had 2 of the same size beakers, wouldn't it? Way too wide. And I don't want any water in there yet. Hang on. Boy, I am struggling today. Let's say in this beaker, should be empty. Sorry for my let's say I want 1 liter of 1 molar solution. I have a 5 molar, 1 liter of a 5 molar solution, and I want 1 liter of a 1 molar solution. So first of all, we call this solution, we usually call it the stock solution. The stock solution is more concentrated. It's usually what you're going to start with, your stock solution. Now, visually, again, if we want 1 liter of a 1 molar solution, that means we want 1 mole per liter. So in this whole liter, I just want 1 mole. Well, my dot represents 1 mole. So what do I have to do? I have to take out the amount of water that contains exactly 1 dot and transfer it over to here. Now that I've got my stock over here, I got my 1 mole, I've got my stock. Now I need to fill up the rest of this with pure water. Get that to 1 liter. Now I'd have my 1 mole per liter. My 1 molar, we'll call this one a dilution. My 1 molar dilution. So that's the concept. That's the concept. We're going to have a very concentrated solution. We're going to need to figure out if we're going to make a dilution, a less concentrated solution. We need to figure out how much of this concentrated solution we're going to need to get exactly, in this case, exactly 1 mole. And that's what these questions are going to ask. So before I get to the questions part, the math part of those, why you guys come to this class. Before I get there, any questions on the concept? Making a dilution. Taking a little bit of a concentrated solution and diluting it with water so that it's less concentrated. Ever start with the idea of what we're doing? Cool. All right. So here's where the math comes in. Generally, they're going to ask, oops, got to be on the camera here. Generally, they're going to ask, how much stock solution is that? If we want to get exactly 1 mole, we don't want 1.1 mole, and we don't want 0.9 moles. We want exactly 1 dot. Well, drawing a line and taking it is pretty easy, but when we go into lab and we have to measure out the exact volume, we need to know exactly how much we're going to try to get. And so that's what a lot of these questions are going to ask. How much stock solution do you need to get, do you need to take in order to make your new solution? Well, how much stock solution is that? We're going to start, as we always do, question mark, milliliters. Now, here's something I wish I'd emphasized a little bit more last week. Got to get better at it, but you're really, really going to want to do this week. 1 milliliter of stock. We can shorten it, right? STCK, or even it's just STK, stock. The reason why you want to tell yourself what you're looking for is, guys, by the end of this, you're going to have a lot of different milliliters, a lot of different liters, liters of stock, liters of dilution, milliliters. It'll be very helpful to you to label what you're looking for, what you're trying to get. How much of this are we trying to take? All right, well, I told you this before. My highest recommendations, always try to start with the number. We've got 3 numbers, right? We've got 5 molar, 1 liter, and 1 molar. Always try to start with the number that has just a single unit. Remember, big M is moles per liter. That's a double unit. Moles per liter. There it is. Start with the number that has just 1 unit. So we're looking for 1 liter, and I'm going to put DLT here. That's my dilution, right? This one here is my dilution. So DLT for dilution, 1 liter of dilution. Okay. Cool, cool, cool. I know what goes in the bottom. At least what unit goes in the bottom. Liters of DLT. It has to go in the bottom so that it cancels out. Where can I go with liters of DLT? Well, how about to moles of DLT? This right here means moles per liter. I want 1 mole per liter. Now, I didn't say what we're working with, moles of what, moles of salt, Moles of sugar, moles of donuts, be a lot of donuts. Moles of money, I'd be the richest man in the world. By far, by like a long way. A mole is a large number, but I didn't say what moles were. I would just use the word mole. So there we go. Liters of dilution is gone, and we're into moles. Now that we have moles, again, we know what's going to go on the bottom. Right? Has to cancel out. How about what goes on top? Where can I go with moles? Well, right here. Now that I have moles, I can say 5 moles in 1 liter of stock. That's what this value right here is. Who cares that it's upside down? 5 over 1, 1 over 5. It doesn't matter. Guys like saying 4 quarters is $1. It's the same thing as $1 is 4 quarters. Who cares which one's on top? I'm traveling 60 miles per hour. Or in 1 hour, I travel 60 miles. Same thing. 5 moles per liter, or in 1 liter, I have 5 moles. It's the same thing, same exact thing. We got to get the units to cancel out. That's the important part. Hey, last step now. This should be the easiest step. I'm hoping we're all getting pretty good at this one. We have liters of stock. We're looking for milliliters of stock. That's a pretty easy conversion. 1,000 milliliters in a liter. Hey guys, big advice, big advice, big advice. Get out your calculators. Give me a minute here. Get out your calculators. Compute that. Compute that. Do that today. We're going to work through a couple of examples. Practice plugging it in. I'd say probably half of you guys are doing perfect with that. No problems, nothing, no mistakes. But again, you guys have been grading your homework, and a lot of you have like a perfect problem set up, and then you gave me the wrong answer. And I generally know what you're doing wrong because I can see what your number is. I know what your number should be. So I want to try to help you guys to make sure you're using calculator right. Again, for my class, maybe not such a big deal. I count the work a lot more than I count the final answer. But does anybody have another class where you do calculations and then you just type in an answer to Canvas and it tells you you're right or wrong? Man, I can't imagine how terribly annoying it might be to plug in an answer there and get 0 points, even though you did all the work. The work might even be right. You just don't know it. You're just not using a calculator. So try it, plug it in, see what you get. I got 200 milliliters of stock. 200 milliliters of stock. I'll try to point out some common errors with your calculator today, because again, guys, it's probably about half of you grading homeworks. About half of you guys are setting up your problems perfectly, but then just getting the wrong answer, which means you're not entering things into your calculator quite correctly. Cool. So 200 milliliters of stock. That means we would need to take 200 milliliters of this material, this stock, put it into our new beaker, and add 800 milliliters of water, pure water. And that would give us our 1 liter of 1 molar solution. So that's the type of problems we're working with. Questions? This has all been pretty conceptual so far. Cool. Let's try an example with slightly more difficult numbers. All right, so this is the type of problem you guys will see on your homework tonight. Here is a dilution. Ultimately, guys, this is the same exact type of problem that we did up here. Only difference is a little bit different numbers. That's it. Maybe a little more complicated numbers, but ultimately it's the exact same as what we just did. They're asking how many milliliters of a 2.00 molar, it's a decimal point there, 2.00 molar MgSO4 solution must be diluted with water to prepare 100.0 milliliters of 0.400 molar MgSO4 solution. Hey, sometimes these bigger problems, guys, it's best to kind of think about what you're doing, maybe identify what you have. Sometimes you might have to reread the question, that's fine, rather than just grabbing numbers and throwing them together and getting lost. So let's take a look at this. What is our stock solution in this? They gave us two solutions, right? They gave us a 2.00 molar magnesium sulfate, and they gave us a 0.0400 molar magnesium sulfate solution. Which one of those two is our stock solution? It says a decimal in there, but yeah, yep. This is our stock solution. So 2.00, you said 200, right? Yeah, you had the right one, but yeah, make sure you get that decimal in there. 2.00 molar MgSO4. The stock is the more concentrated. This is more concentrated than that. 2 is more than 0.4. So this is our stock solution. Okay. That means this is our dilution. Cool. How many milliliters of stock? That's what they're asking for. Cool. We're ready to set this bad boy up. How many milliliters of 2 molar MgSO4? How many milliliters of our stock? And that's what this one is equal to, and we've got three numbers we could start with. My best advice, choose the number that only has a single unit. Milliliters. This one is moles per liter. This one is moles per liter. Hopefully we're getting pretty good at seeing that big M and immediately just kind of in our head transferring big M to moles per liter. That's just milliliters. So 100 milliliters. Now here's my question. Is that a dilution or a stock? Excellent. Yep. People at home, Ethan said dilution. Absolutely. 100 milliliters of our 0.4 molar MgSO4. That's the smaller of the two. That makes this our dilution. This one's our dilution, guys. I'm telling you, I know some of you guys don't like to add the little extras. It really does help. It really does. All right, so now that we've got that, this is what we're starting with. We know we're working with moles. Molar. That's moles per liter. So we kind of want to turn our milliliters into liters. We're working with molar. That's with liters. So first step, hey, this should be an easy one. 1,000 milliliters of dilution equals 1 liter of dilution. That's because 1,000 milliliters of anything equals 1 liter of that same thing. Cool. Now milliliters is gone. We have our 1 milliliter of dilution. We know what's going to go on the bottom down here. Liters of dilution. I don't put a number there just yet. I'm not sure what my number just yet. Mom, are you staying with us? It's a little too comfortable back there. What do I have? Where can I go with liters? Yeah, excellent. With liters, I can go to moles. Here's my question though. So that's molar right there. That's big M. Which one do I want to use though? The 2.00 or the 0.400? And that to me, that's where having this DLT, dilution, that's where that really, really helps. Which one of these two is our dilution? What's that? The 0.4 is our dilution. This one's the stock. It's more concentrated. This one's the dilution. That's the one we want. 0.400 moles per liter. Dilution. That's the less concentrated of the two. Okay. And we got moles now. We don't want moles. We got to keep going. Not quite there yet. I know I need to get moles on the bottom. Got to get moles on the bottom. Why? Because I need to cancel it out. I don't want it there, so I need to cancel it out. I put it on the bottom. Where can I go with moles? MgSO4. Guess what? We go back to liters, but this time we're going to liters of stock, right? We had liters of dilution. Now we're going to liters of stock. Again, we just got to look up at our question. We got to remember which one is our stock solution. That's the more concentrated of the two. That's the 2.00. So 2.00 moles per liter of stock. One more conversion. It's a very easy one. We have liters of stock. We want milliliters of stock. Thousand milliliters to a liter. Woo! Looking pretty. For those of you who like to cancel out your units, check this out. Milliliters dilution is gone. Liters of dilution is gone. Moles of magnesium sulfate is gone. And liters of stock is gone. We're left with milliliters of stock. We can calculate. Again, my recommendation, guys, plug this in just to make sure you're getting the right value. $20.0 milliliters of stock. No, my calculator didn't tell me the 0.0. It just said 20. I had to be a little bit smarter in my calculator. 4 significant digits, 3 significant digits, 3 significant digits. I need 3 in my final answer. So there it is. Guys, I'm guessing some of you got 80. If you got 80, the reason why is because you see 1,000 here and you see 2 there, and you think you need to multiply them together because you're like, well, they're both on the bottom. They're both together on the bottom. Don't do that. Anything that's on the bottom, hit the divided by sign in front of it. So 100 divided by 1,000 times 0.4 divided by 2 times 1,000. So if you got 80, what you probably did is you hit 100 divided by 1,000 times 2 times 0.4 times. Don't do that. If it's on the bottom, hit divided by. I know it looks like you're doing 1,000 times 2, but you want to hit divided by there. Questions? Hey, I've got 3 more examples for you guys. The next one, though, is pretty much the same as this. Do you guys feel comfortable with this type of problem? And we should just skip that one and do the last 2? Or do you want to see this type of setup again? Would that be helpful to say it one more time? This one? What's that? Got one vote for moving on. No one else cares. What's that? Okay. All right. All right. So that means you guys are comfortable with this. You're going to see this a couple times in your homework tonight. Cool. Let's look at a different type of problem then. All right. So very similar, but it's got its differences here. Got its differences. How could you prepare 250 milliliters? And that decimal point is important. That decimal point means the zero is significant, so this number has 3 significant figures in it. 250 milliliters of a 0.2 molar NaCl using only a solution of 1.0 molar NaCl and water. Hey, once again, sometimes you got to reread it. And before you even get started, we've got to figure out what we've got. So what is our stock solution? Is it 0.2 molar NaCl or 1.0 molar NaCl? Yep, our stock solution is the bigger one, the more concentrated one. So our 1 molar is our stock solution. So we're trying to make 250 milliliters of a 0.20 molar. That's our dilution. That's our diluted version of that. All right, so how could you prepare? How could you prepare? Okay, well, just like the example we started with and the demonstration at the beginning, just like this, what we're looking for is how much of our stock solution. How many milliliters of stock solution is equal to, hey, we've got 2 values here that are double values, moles over liters, moles over liters. And a single value over here, milliliters. Whenever you are able, start with the single unit. Is that stock or dilution? Yep. That's 250 milliliters of my dilution. Let's put that DLT. And now we're ready to roll. Hey, milliliters don't do us a whole lot of good when we're working with moles. First thing, let's go from milliliters to liters. Next step, hey, we know what we need on the bottom. Liters of dilution. On top, guess where we can go with liters? We have molarity, so we can go to moles. The big question, though, 0.2 or 1.0? This right here should help us. Yep. We're working with our dilution. There's that huge, huge advantage of spending the extra 3 seconds it takes to write DLT. We're looking for dilution. Our dilution was 0.2. All right, continuing on, the next line here, we know we need moles NaCl on the bottom. This time we can go from moles to liters, but not just liters, liters of stock. So we came from liters of dilution, now we go to liters of stock. We just have to know which one of these two represents our stock. It's the more concentrated one, so it's 1 mole per liter. That's our stock. Finally, then, the easiest conversion we have, we are hopefully very familiar with it by now. I have liters, I need to go to milliliters. And there we go. And for those of you guys who get satisfaction, crossing out your units. We're left with just milliliters of stock, which is exactly what we were looking for. .50 milliliters of stock. Yes, that decimal place is important. The decimal point's important. We need 2 significant figures. We've got 3 there, 2 there, and 2 here. So we need 2. So I got to put that decimal point behind the 50 point. That makes the 0 significant. So 5 and 0 is my 2 significant zeros. Not my final answer. I'm not circling this yet. Look at the question. How could you prepare? Simply saying 50 milliliters of stock isn't an answer to that question. So we need to put this in kind of a sentence here. Add 50 milliliters of stock to how much water? What's that? How much total volume do we want? What's that? We want 250 milliliters, right? Our final volume, we want to be 250 milliliters. We have 50, so how much water are we going to add? You guys remember last week we talked about making solutions, and you got to make sure you add the salt first, and then you got to say something like add water up to 200 milliliters. We don't have to worry about that for these because they're additive. You know, if you got 50 milliliters and you want to get to 250, you add 200. So we don't have to worry about displacement. We know our volumes here, so. The order of what you add first doesn't matter. I could add my stock to my water. I could add my water to my stock. Does not matter. Additive. Okay. Another example, a little different here. All right, so a little different type of problem here. Again, something you might see on your homework tonight. Let's say you have 25 milliliters of water added to 125 milliliters of a 0.15 molar NaOH solution. What will the new molarity be? See, they're kind of asking us a little bit different type of problem here. We're looking for molarity. That's question mark moles over liters. Now I'm going to put DLT there. Again, it's going to kind of help me keep track of stuff. This is what I'm looking for. I want moles of NaOH over the liters of my dilution. Hey, here's the cool part, guys. They already gave us the moles. They already gave us the moles. And that's not going to change. We're not adding more salt. We're not adding more NaOH. The moles are going to stay the same. We've already got moles. We just got to make sure we get it on top. So 0.15 moles per liter. Now I got to put stock here. That was my stock. That was my concentrated solution. So I'm not done on bottom yet. I'm done on top. Don't have to do anything with the top, but I do have to get this stock into dilution. It'll take a little bit of thinking, but I think we're okay, especially since I'm helping out. Okay, well, our first step, we got to go stock on top, liters of stock on top. Why is that? Well, because we need to cancel out. I'm working with milliliters, so let's go milliliters. Cool, liters of stock is gone. We're into milliliters. Do we have a milliliters of stock? Yeah, actually we do. Look, we have 125 milliliters of our stock solution. So I want to put it on top so it cancels out. How about a dilution? Do we know our total volume of dilution? Sure. So the total volume. We added 25 mils of water, but what did we already have when we added it to? Excellent. And guys, if you see this, you can just write 150. If you know what I'm doing, I'm going to show my work just because I want you guys to be able to see it. But if you see it, you're like, oh yeah, I get that. Just write 150. Thank you. Yeah, how do I get my DLT? My dilution? I had 125 milliliters of stock and I added 25 milliliters of water. And if you see that, and you're like, oh yeah, that's what our volume of stock of our dilution is. Awesome. Just write 150. 150 be great. 150 is awesome. Go for it. Final step then, we don't want milliliters of DLT on bottom, we want liters, but that's a really simple conversion. There it is. Again, I invite you to plug it along in your calculator, just kind of make sure you're entering things correctly. You know, when you get home, you really don't have that option, right? Like you're going to enter it in your calculator and you're going to write down whatever you see. You don't have someone telling you, hey, that's right or that's wrong, you're making a mistake. You just got to take what you take. So check with your calculator here. Make sure you round to the appropriate number of digits. Our new concentration will be 0.13 molar. My calculator said 0.125, but again, we only have two significant digits, just two right there. So I round that 2 up to a 3 because the 5 behind it is enough to go up. Cool. One more, and this one's just way out there, but it's also super easy. If you set it up correctly, it's the easiest one we do. Yeah, what would an example in this problem, this chapter do without a concentration volume to volume? Got to have one of these in there, right? Just to change things up a little bit, make it more everyday American. Hey guys, I think I've got this one in here just to show you guys if you're doing the right thing, if you're taking the right steps, which I know a lot of you guys are. I've been really impressed with your homework. It's looked great. So a lot of you guys keep it up. This would be a simple, easy problem for you. But guys, for some of you, I know you're not taking the time to do things right. You're going to end up giving yourselves a big headache because it's going to turn into a big mess. But if you take your time, set this problem up right and slowly and do it correctly, it'll look fantastic. Okay. What they're looking for is the concentration percent volume to volume. So let's start with that question mark. And here's the part a lot of you guys aren't doing. Drive me nuts. Most of you guys are. Great job. Keep it up. We're looking for volume, that's milliliters of solute over milliliters of solution. That's what a percent volume to volume is. How much solute per solution? Okay, well, what's our solute? What is our solute in this one? Of perfect. Yep. So to answer my question, ethanol is the solute. Kara gave me not just the solvent, the solute, but also the volume of it. So wait a minute. What did you say? 25 milliliters of ethanol? Do I have everything I need for the top? Yeah. Yeah, ethanol is my solute, and I've got my volume already. Guys, we're set. We're set on top. 25 milliliters of ethanol. 25 milliliters of solute. They told us. How about solution? How about solution? How much solution do I have? Yeah. Guys, they gave us that too. Look at that. Look at that. They gave it to us. They gave it to us. We're done. Well, okay, one more thing. I always got to multiply it by 100%, but that's it. That's that whole problem right there. That's the whole. Could they have made it a little more complicated? Sure. They might have said diluted with 150 milliliters of water. If they said with, what would you have to do? Yeah, if they said with 150 milliliters of water, you'd have to add the two. You say, well, then your total solution is 175. But they didn't even say that. They just said we have a total volume of 150 milliliters. So, I mean, that's it. That was a simple problem. We set ourselves up and then we knocked them down. We're our own setup men. 25 divided by 150 times 100. With appropriate sig figs, we have this big long number here with appropriate sig figs. Just 2 in the 25, so 17%. Hey, bonus question. Bonus question. I know you don't want your favorite class the whole week to end. Bonus question. You guys remember this from last week? How do we find a proof? Yep, we double it. Pretty easy. We double it. Hey, watch out. The answer is 33 proof. How many of you guys said 34? Probably all of you. Probably all of you. It's really 33. Hey, you know, I keep telling you guys to underline extra digits and carry them. Don't just round them off. You get round off error. Well, guess what? The 17%, again, we rounded that up because we only wanted 2 digits. But when we come down here and do this part, yeah, we've only got 2 significant digits. So I underline those extras. But when I multiply that by 2, I get 33.33, which rounds down to 33 proof. So here's one of those advantages. You know, I'm always telling you to underline your extra digits. Don't round them off. You get round off error. Well, that's exactly what round off error is. You just missed your proof by 1 proof if you called it 34 because you rounded too early. So there's the advantage of underlining and keeping your extra digits. I finally got a way to show that to you. Cool, cool, cool. All right, people at home, I've got some bad news for you. You guys are done with your favorite class for the whole week. I'm sorry. I'm sorry. That's too bad.